Now, we're going to take up one more problem on overhanging beam. The problem number 35. Draw the SFD and BMDs for the loading pattern on the beam shown in figure. Indicate where the contraflexion, that is inflection points, are located. Also, locate the maximum bending moment with its magnitude. So here we have a overhanging beam and equally overhangs on either side of A and B. A to C will going to have 2 meters and B to D will going to have 2 meters, and between A and B it will go to be 10 meters, so that the length of the beam will be equal to 14 meters. And we have a 5 kilonewton uniformly distributed 5 kilonewton per meter of uniformly distributed load for the entire span. So since now we are going to take the support reactions. Take the support reaction says because due to symmetry. So what we're going to have RAV will be equal to RBV. So that means it is equal to 5 into 14 by 2. So that will be equal to 35 kilonewton each on RAV and RBV. Now we go for the shear force diagram. SF at C will be equal to 0. So then SF at A will be equal to 5 into 2 minus 5 into 2 plus 35 kilonewton. So that will be equal to plus 25 kilonewton. So here what happens? At the point A, we have the end of the uniformly distributed load and also the point load is acting. Since between C and A, if you are considering without the point load, then SF at A will be equal to minus 5 into 2 will be equal to minus 10 kilonewton. Then at the point A, when we are considering the point load, it becomes plus 35, it becomes plus 25 kilonewton. Then SF at B, the same principle is applied. As the UDL approaches to the point B without considering the point load, it will be plus 25 minus 5 into 10, which will be equal to 50 minus 50 plus 25 will be equal to minus 25 kilonewton. Since you have the point load at the point B, then add plus 35, it will become 25 minus 50 plus 35 will be equal to plus 10 kilonewton. So then what we have, SF at the point D will be equal to plus 10 minus 5 into 2, it becomes equal to 0. So this is how it will going to work. SF at C will be equal to 0. SF at A will be equal to minus 10 kilonewton between C and A. As you have an uniformly distributed load, varies from 0 to minus 10 kilonewton linearly because due to UDL. Because of the presence of because of the presence of point load at the point A of 35 kilonewton, SF varies suddenly increases from minus 10 kilonewton to plus 25 kilonewton. Then between A and B, as SF has got a UDL, it drops from it decreases from plus 25 kilonewton to minus 25 kilonewton. At the point B, because due to the point load of 35 kilonewton, it increases from minus 25 to plus 10 kilonewton. And again from B to D, SF is varying from uniformly distributed load, it drops to 0 at the point D. And since you have a UDL, variation takes place in the UDL because of linear variation. Similarly, SF varies from 0 to minus 10 kilonewton according to the equation of straight line due to UDL, and then changes suddenly to plus 25 kilonewton due to reaction at the point A. Then what happens? SF varies from plus 25 kilonewton to minus 25 kilonewton according to the equation of straight line due to UDL, and then changes suddenly to plus 10 kilonewton because due to the reaction at point B. And also it varies according to the equation of straight line due to UDL, it becomes 0. Then we have the bending moment diagram. In the bending moment diagram, BM at the point C will be equal to 0. Then BM at the point A will be equal to minus 5 into 2 into 2 by 2. So that will be equal to minus 10 kilonewton meter. Bm at B will be equal to minus 5 into 12 by 2 plus 35 into 10, which will be equal to minus 10 kilonewton meter. So that is because as the load is acting from the top, the bending moment hogs. Since it is a hogging bending moment, you will going to get negative, that is minus 5 into 12 by 2, plus as you have a support reaction from the bottom direction, so the bending moment will going to have a sagging bending moment between B and A. So because of the sagging bending moment, by convention it becomes positive. So plus 35 into 10, which will be equal to minus 10 kilonewton meter. Then Bm at the point D will be equal to, again you have a again you have a hogging bending moment, that is 5 into 14, minus 5 into 14 into 14 by 2 plus 35 into 12 plus 35 into 12 plus 35 into 2. So it becomes equal to 0. So this is how you will be able to get the points. Bm at the point C will be equal to 0. Bm at the point A will be equal to minus 10 kilonewton meter. So since it is a variation is a square, so therefore you will going to get a parabolic curve between 0 to minus 10. Bm at the point B will also be equal to minus 10, and we cannot join from here to here because the shear force changing its sign from positive to negative at this point. So therefore, when the shear force changes its sign from positive to negative at that particular point, we will going to get the maximum bending moment. So therefore, we need to find out at what distance you will going to get the shear force is changes its sign, point number 1, and the point number 2, at that distance what will going to be the maximum bending moment we need to calculate. So therefore you cannot plot this from directly from here to here. So we need to find out what will going to be the distance at which the shear force changes its sign, that we need to identify. Therefore, and the Bm at D will be equal to 0 since you have the point from B to D. So from B to D you have a parabolic curve because it is UDL. Now once you get this, so we need to find out what will going to be the maximum bending moment. The maximum bending moment will occur at a point where shear force changes its sign. Shear force changes its sign at E, A, E and B. Hence the bending moment is maximum at the point A, E and B. So maximum negative bending moment at the supports, that is at points A and B, it will be equal to minus 10 kilonewton meter. And then we need to find out, due to symmetry, the point E is at the midspan. Due to symmetry, the point PE is at the midspan, that is 7 meters. Bm at E will be equal to minus 5 into 7 into 7 by 2 plus 35 into 35 into 5, that is 7 minus 2 will be equal to 5. So on simplification, you will going to get it as 52.5 kilonewton meter. So at the point E, you will going to get the maximum bending moment, which is 52.5 kilonewton meter. So then from here, you join from minus 10 kilonewton meter to plus 52.5 kilonewton meter by parabolically. Then again from 52.5 kilonewton meter to minus 10 kilonewton meter, again you join it by parabolically because the entire span is made out of, between A and B, the entire span is made out of uniformly distributed load. Therefore, you will going to get the sign changes from negative to positive at the point F, and then from positive to negative at the point G. That is because due to the point of contraflexion. So the maximum bending moment at the point E will be equal to plus 52.5 kilonewton meter. Now we need to find out the point of contraflexion, which is called inflection. It is the point where the bending moment changes its sign. The points of contraflexion are at the points capital F and capital G. So let the distance of F be x meters from C. Bm at F will be equal to what will going to be the magnitude of the bending moment at this point where the bending moment changes its sign. So obviously it should be 0. Therefore, considering at that section, which will be equal to minus 5 into x by 2 plus 35 into x minus 2. So minus 5 into x by 2 plus 35 into x minus 2. So that will be equal to minus 2.5 into x square plus 35 into x minus 70. So on simplification, x squared minus 14x in plus 28 is equal to 0. So you take the equation as x will be equal to 14 plus or minus root of 14 square minus 4 into 1 into 28 by 2. So on simplification, you will going to get it as 11.5826 meters or 2.4174 meters. So therefore, that is the point of contraflexure at F is 2.4174 meters from C. By symmetry, the point of contraflexure is at G, which is 2.4174 meters from D or 11.5826 meters from C. So this is how you will be able to analyze the shear force diagram, the bend moment diagram, and also to find the support reactions and also the maximum bend moment and the point of contraflexure. This is how you will be able to solve this particular problem. Thank you.